Welcome to this FP2 video on further regions in an Argand diagram. So this isn't particularly difficult, it's just continuing on from last time with a few more slightly harder problems. But I do feel that it is much the same as the previous video. But just following your textbook so you can line it up with what's being taught to you in class. So we're looking at using inequalities to represent regions in an Argand diagram, much the same as the previous one. The inequality like this, so where I've got theta or two values of theta, okay, where arg z minus z1 is between the two values, describes a region in the Argand diagram that is enclosed by the two half values. So, is enclosed by z minus z1 equals theta 1 and arg z minus z1 equals theta 2. Okay, if we've got a less than or equal to and a greater than or equal to here, then the lines that you draw will be bold. If we just have a less than or we just have a greater than, then the lines would be dashed to represent that they're not included those. But in both cases, Z1 will not be included. So if you imagine in these cases, you've got Z1 here, and then we've got say two lines coming off here, so theta 1 and theta 2, and this region between these two lines is your theta 2 minus your theta 1, and that would be your kind of shaded area. So shade that area in like so, that region. And I'm pretty sure this was kind of covered in the last video, but hey, we're just following along nicely with in line with the textbook. So let's keep doing that. So without further ado, let's jump into the first example. So I've got four diagrams coming up. Here's the first one, and we've got to describe algebraically this shaded region. Okay, so I'm told that this is the point minus 4, 2, and it crosses the y-axis here, or the imaginary axis, at 6. So it's crossing two lines. This line here is going to be arg z minus, now it's minus 4 plus 2i in there, and this is going to cross at 0. Okay, and then we want to work out this line here. Now to work out this line, I need to go and look at where my point is here and my point is here. So of course I can work this out, work this angle out, because I know this distance and this distance. This distance is 4, this distance is 4. So I know that this is 45 degrees, or pi by 4. Sorry, I don't need to write pi by 4 in there. We want to write arg z minus 4 plus 2i equals pi by 4. So those are the two angles that I'm looking at. Okay, so when I describe this, I've got arg z, now minus 4 is going to be plus 4, and then this is going to be minus 2i. So I want plus 4 minus 2i. Now, when it equals to 0, this line is a dashed line. Don't know if you can see that well on your screens, but this is a dashed line, so this one is just going to be it's greater than, whereas this one is a bold line, so that's going to be a less than or equals to. So it's greater than 0, less than or equals to pi by 4. And that is the first one done. Right, next diagram. So notice this time we have two bold lines, so it will include the lines, and here is my Z1 at 2, root 3 and 2. Now this is going to be, this one here is going to be at 90 degrees. So that is arg Z minus 2 root 3 plus 2i. And this is going to be equal to pi by 2. And then this one, arg Z minus 2 root 3 plus 2i, and this one's going to be equal to, right, so I need to work out this angle here, call that theta. Okay, so we got opposite and adjacent, isn't it? So tan theta is opposite, which is 2 over 2 root 3, which is pi by 6. So this angle here will go from this way round to this way. Yeah. So if you think about it, and I'll do this in red because this is the line we're measuring against. Positive is that way, and then these ones then are negative because we measure between minus pi and plus pi. So the size of this angle here is going to be minus 5 pi by 6. Okay, so there I have both of my values. Now it's just left to put them together. So we've got arg Z minus 2 root 3 minus 2i. Now the bottom value is going to be this pi by 2, and then this will be the top value, won't it? So in this kind of case, it doesn't really make sense to write greater than or equals to pi by 2 but less than or equals to minus 5 pi by 6. So in this case I would go outside of the normal range of being between pi and minus pi, and I'd add 2 pi to this value, and I get 7 pi by 6. And that way we keep the upper value larger than the lower value. Now, what happens if the shaded region is the other side? So in the last example, the shaded region was this side. This is exactly the same otherwise in terms of our two half lines, but the shading is this side. So this time it's going to be between, so we go arg Z minus 2 root 3 minus 2i is greater than or equal to minus 5 pi by 6 and less than or equal to pi by 2. So we swap these around because we're going in this direction. Okay, so there we are, nice and easy for that one. Let's look at one more of these examples. So this one, shaded region, is within a circle and between two half lines. So let's start with the circle first of all. So the circle is Z minus 3 minus 2i. And it has a radius of 2. Okay, so that is therefore z minus 3 plus 2i less than or equals to 2. So that gives me that one. Now I need to look at the half lines. So we've got an argument of z. Now z is now minus 5 plus 2i, and it's this point here. And then this one is going to be at pi or minus pi. Okay, so for that we'll stick with pi first of all, but it could be using minus pi. So I will put or minus pi in there. And then to get this line, well, this distance here is 2, this distance here is 2. I don't even need to do the trigonometry for this one. It's going to be 45 degrees or pi by 4. Okay, so this angle here is 45 degrees. So we get arg z minus 5 plus 2i is equal to, so I've got, going this way, we've got pi minus pi by 4. So pi minus pi by 4, which is 3 pi by 4. Okay, so there we have our argument. Okay, our two half lines, and what we need to do now is put these two together. So z is an element of the complex numbers where z minus 3 plus 2i is less than or equals to 2, and that is intersecting, so and z is an element of the complex numbers. Now we're going from the 3/4 pi down to the pi. Okay, so this is the one we want. So we want 3/4 pi, and arg z is greater than that, so arg z minus 3 plus 2i and less than or equal to pi. Oh, sorry, it's just less than pi because it's a dashed line. And that is the answer. So that's the describing terms algebraically. Let's go like in reverse from the algebraic terms now for another example. So we've got two kind of rules to look at. So this one is, I should recognize this as a circle. This one, real z, is going to be two vertical lines. So let's get into this. So let's deal with the circle first. So let z equal x plus I y. So then we have 2x plus I y minus 2 less than or equal to x plus I y. Now I want the x's together. Like so. Now let's square. And when I square it, I get this as 4. And then I've got x minus 2 squared plus y squared. And then it's x squared plus y squared. So this is 4, and then x squared plus, minus 4x plus 4 plus y squared, and x squared plus y squared. So 4x squared minus 16x plus 16 plus 4y squared minus x squared minus y squared is less than or equal to 0. So 3x squared minus 16x plus 3y squared plus 16 is less than or equal to 0. Divide by 3, so we get x squared minus 16 over 3 x plus y squared plus 16 over 3, and then complete the square, so we get x minus 8 over 3 squared minus 64 over 9 plus y squared plus 16 over 3. And I get x minus 8 over 3 squared plus y squared is less than or equal to 16 over 9. So this describes a circle, or the region shaded in the circle. The circle has center 8, 3, 0 and radius 4/3. Okay, so we've got that down. Now, real z being between 3 and 2 describes the region between x equals 3 and x equals 2. So x equals 2 and x equals 3. So let's look at what this looks like on the diagram. So I've got a set of axes. I'm going to plot this on my diagram there, roughly right. Well, doesn't really need to be perfect because it's not to scale. So 8, 3, 0. Now 8/3 minus 4/3 means that this point is at 4, 3, and 8/3 plus 4/3, this point is at 4, and 8/3 is 2.6 recurring. So for the vertical lines going through 2 and 3, I'm going to be kind of roughly there and there. They don't obviously have to be perfect, it's a sketch, but obviously they need to make sense. So this is now shaded within the circle, so the whole circle will be shaded if I just had this one, and shaded between these two lines, so all of between these two lines will be shaded if I just had this one. Putting them together and I get the shaded area between the two lines that then stays within my circle. So I'm looking at that. Okay, and that's really all there is to it on this one. Hopefully not too difficult, and you shouldn't have had too much of a problem following that one. Now, before we get into the questions, if you found this video useful so far, don't forget to hit that like button. If you're yet to subscribe, subscribe now. Obviously it helps me out, I don't need to tell you that, But yeah, it just makes it easier for you to find my future videos if you need help. And if you are, long time member of this channel, or viewer of this channel, I should say, please consider joining as a member to help me out financially, but only if you're willing and able to. Otherwise, let's get into the questions. So, 4 questions for you, all past paper questions. Pause the video now. Welcome back. Let's have a look at the first question. So let's first look at this one. So arg z plus 1 plus I is arg z minus 1 minus I. So this is going to go through the point 1 minus 1 minus 1. So say here. And then it's between minus pi by 4 and minus pi by 2. So if we think this is going to be, 0 round to pi by 2, pi, if we go in the other way, this is 0, minus pi by 4 is this 45 degrees, minus pi by 2 is straight down. Okay, so minus pi by 2. Now, because it's not a strict inequality, it equals as well, this line will be included. So straight down there, and then 45 degrees straight across there. And it's between these two lines. Okay, so it's inside this area here. Incidentally, because it's 45 degrees, or 45 degrees, below my horizontal here, below the real, this means that this should, because it'll be 1 across, 1 down, this should cross here at minus 2, so 0, minus 2. Okay, now let's look at the second one, so this part. So we've got z minus 1 minus 2I less than or equal to 1. Now this is going to be a circle. I'll do this in a different colour, so I'll do this in red. Minus 1 minus 2, so minus 1 minus 2. This is the centre of the circle, and it's going to have a radius of 1. So that will look something like this. And then this is the area in here. Let me just... this area in here. Okay, so that is going to be my region. Oh, this will be pi by 4, that angle. Not that you require that, but that's it done. Okay, let's move on to, and that was part A. Let's move on to part B. So looking at part B now, let's first look at this one. So we've got 2z minus 6 less than or equal to z minus 3. So that's 2. Now z is x plus I y. X plus I y minus 3. So that's 2x minus 6 plus I y. And this is x minus 3 plus I y. Now this equals x minus 6 squared which is 4 x minus 6 squared plus y squared x minus 3 squared plus y squared. So x squared minus 12x plus 36 plus y squared, and this is, x squared minus 6x plus 9 plus y squared. Now multiply by 4, 4x squared minus 48x plus 144 plus y squared less than or equal to x squared minus 6x plus 9 plus y squared. So this is 3x squared. Now I'm adding 6x, so it's minus 42x. Now 144, now I'm taking away 9, so that's that plus 135, and obviously I'm taking away, forgot that, 4y squared there, 3y squared. Now we can divide by 3, so 42 divided by 3 is 14x, 135 divided by 3 is 45 plus y squared. Now complete this square, so this is x minus 7 squared minus 49 plus 45 plus y squared. Okay, now I'm just going to carry on up here. So x minus 7 squared plus y squared. Now minus 49 plus 45 is minus 4. Take that to the other side. Takes a 4 to the other side. So there I have now a circle. So circle, center, 7, 0, radius 2, square root of 4. So that's that first one. Now let's look at this second one. So real z is less than or equal to 7. Now this is just the vertical line going through 7. So let's draw a set of axes. So I've got a circle of radius 2, and that will be like that. At 7, 0. Then I've got real z less than 7, so that's going to be this horizontal, or less than or equals to. So it is also equal in that, so that's going to give me that line. And that is my shaded region. Okay, so this is, at 7, 0, the center, and this vertical line goes through the 7 there. Okay, and that is the shaded bit. And it was a little bit small, but you get the picture. Right, let's go on to question 2. So part A, shade on an Argand diagram the region defined by z plus 6 is less than or equals to 3. So here's my Argand diagram. there. So 2, 4, 6. So this circle here is going to have the center minus 6, 0. And it's going to have a radius of 3. And it will look something like this. Okay, so this is part A. Now, part B, the complex number Z satisfies that circle. Find the range of possible values of argz. So, for this, we need to go from the origin to the points where it touches the circle. So, something like that. Let me just get this one right. It's quite hard to draw, but something like that. Now, we also know that where it touches the circle, it's going to make a 90-degree angle. Okay, and we know that this distance here is 6 and this distance is 3, and this distance is 3 here because it's a radius. So in terms of this angle, if I call this theta, then sine theta is opposite over hypotenuse. Okay, so that sine theta is a half, which means that theta is 30 degrees or pi by 6. Okay, so that's the size of theta. Now, where it hits up here, I'll call Z1, and where it hits down here, I'll call Z2. So at Z1 now, this is going to be, if you think about it, this is obviously 0 round to pi. So pi minus pi by 6. So pi minus pi by 6 is going to be 5 pi by 6. So arg of Z1 is 5 pi by 6. Now, obviously, normally we deal with down here as negatives. Doesn't make sense to deal with a negative in this case. So we'll keep going around here. So this one at Z2 is going to be pi plus pi by 6, which is going to be 7 pi by 6. Therefore, for any Z satisfying Z plus 6 less than or equals to 3, arg Z is between 7 pi by 6 and 5 pi by 6. Okay, and that is question 2 complete. Okay, question 3. So we need to indicate on diagram set of points satisfying both. So arg Z minus 8 is going to be at 8. So here, and 3/4 pi is going to be like that, because that's 3/4 pi. And then pi is along here, so this is the region here between this line and this horizontal to my left of my point 8 minus 8 sorry, comma 0. Okay, so also the imaginary less than or equals to the real. So before we go on, this is the area that I'm currently looking at. Now, z equals real is going to be this line here, basically y equals x. Oh, should have done that in black, doesn't matter. And then imaginary less than real is going to be below that. So this is now the region that satisfies them both. This triangle here. Okay, so that's that one. Now let's move on to find the exact area of this region. So this is pi by 4. And what we basically want to do is find the height here. Now I can surmise the height here from my diagram, because this angle here is also pi by 4, which means that this is going to be at 4, 4, or where the two lines intersect. So the area is going to be half times the base times the height, which is 4. So that is 16 units squared. That was a relatively easy question. Let's move on to the final question. Okay, shade the region of the Argand diagram described by. Right, so let's deal with this first of all. This is going to be a circle. So z minus 3 plus 2i greater than or equal to root 2 z minus 1. Now let's replace z with x plus iy. And then let's rearrange to get the real and imaginary together. So x minus 3 plus y plus 2i x minus 1 plus iy. Now then, this is x minus 3 squared plus y plus 2 squared, root 2 x minus 1 squared plus y squared. I often do jump to this line here when I'm doing these, but I'm just taking every step while going through this. Now let's expand. So x squared minus 6x plus 9 plus y squared plus 4y plus 4. X squared minus 2x plus 1 plus y squared. So x squared minus 6x plus y squared plus 4y plus 13. 2x squared minus 4x plus 2 plus y plus 2y squared. So there's 1x squared. Now we're adding 6, so plus 2x plus 1y squared minus 4y. And then we're doing 2 take away 13, so minus 11. Now let's complete the square, so x plus 1 squared minus 1 plus y minus 2 squared minus 4 minus 11. So minus 11 minus 15 minus 16 taken to the other side is 16. So x plus 1 squared plus y minus 2 squared. So we've got a circle, centre, minus 1, 2, radius 4. So circle, centre, minus 1, 2, radius 4. So let's rub all of this out because we don't need this anymore. Okay, so let's draw our circle on. So we want an Argand diagram. And we want a circle, centre, minus 1, 2. So say here. And a radius of 4. Let me just draw my circle. And that's roughly right. Okay. So next we need to draw this. So it's an Argand diagram starting at minus 1, minus 2. So minus 1, minus 2, so it's the bottom of this circle. And it goes through 0 and includes 0. So this is this horizontal line here. And then pi by 3. So that would be, 60 degrees basically. So something like that, where this angle is pi by 3. And then the shaded part is going to be between those two and within the circle. So this part of the circle here. Okay. Now, part B is find the exact area of the region. So let's mark this out. We need area of a segment. So we need to find this value of theta. Now, these are both radiuses. So if I call this alpha, and this is also alpha. And this at the bottom here is going to make a 90-degree angle with the radius because it just touches it in one place. This is horizontal and that's in line with the center. So pi by 2 minus pi by 3 is equal to pi by 6. Because that's 3 over 6 pi and 2 over 6 pi. So that is my value of alpha. And then theta is equal to pi minus 2 alpha. So that's pi minus 2/6 or pi by 3. So that's 2 pi by 3. So that is my value of theta. Then the area is half r squared theta minus sine theta. So half times 16, the 4 squared, minus 2 pi upon 3 minus, now sine 2 pi over 3 is root 3 over 2. So this is what we've got, which is 16 pi by 3 4 minus 4 root 3. And that is part B done. So part B was all in red. Now part C, the complex number Z lies in the region R. Find the maximum value of the imaginary Z. Now the largest imaginary point is going to be where this line intersects up here. So what we need to do is find the equation of this line. I'm not sure if anyone does find an easier way to do this. Please let me know in the comments. But the way I thought of doing it is to find the equation of this line and then basically equate the circle and this line to find out where they intersect. So this line has an angle here of pi by 3, 60 degrees. And if I'm going to just change colour here. If I think of, drawing that line like that, that angle there is what's going to give me, because it's to the horizontal, it can give me the gradient. So tan of pi by 3 is root 3. So the gradient is going to be root 3 because tan is opposite over adjacent. So this is the same as root 3 over 1 or just simply root 3. Okay, so that's going to give me my gradient. Now it goes through this coordinate down here, which is -1, -2. So I know y minus y1, which is -2, equals m x minus x1, which is -1. So I've got y plus 2 equals root 3 x plus root 3. So y equals root 3x plus root 3 minus 2. So this now is the equation of this line. And the equation of the circle was x plus 1 squared plus y minus 2 squared equals 16. I know we had like less than or equals to 16, but in terms of the actual equation of the circle, it'll be equals to 16. And what I need to do is put this into this. So that's going to give me x plus 1 squared plus, now instead of y I got root 3x plus root 3 minus 2 and then minus another 2 is going to give me -4. Now expanding my brackets, I got x squared plus 2x plus 1 from the first bracket expanded. Then root 3 times root 3, so that's going to give me 3x squared. And then I've got plus 6 minus 8 root 3x plus 19 minus 8 root 3 equals 16. Now sorting this out, so I've got 4x squared, and then I've got plus 8 minus 8 root 3x, adding the 2x to this, and then add the 1 to this gives me 20, and then take away 16 will give me 4. So plus 4 minus 8 root 3. So that's my A, my B, and my C. Now, I can make it a little bit easier by dividing by 4, like so. But even if I don't divide by 4, I'm using the formula in this case. So now I'm doing the formula. So x is minus b. So we got minus 2 root 3 plus or minus the square root of 2 minus 2 root 3 squared minus 4 times 1 times 1 minus 2 root 3 all over 2 times 1. Okay, now this gives me two values of x. So x is equal to minus 1 plus 2 root 3, or x equals minus 1. Now this one we've already got. X is minus 1. This will give me y equals minus 2. That one we've already got. This one is the one that then is going to lead me to this value. So obviously this one's minus, this side. This one, 2 root 3 minus 1, is the positive x value, which is going to give me this one. So just moving that up to give me more room, we've got y equals root 3, and then I put my x in, plus root 3 minus 2. So I'm subbing this into here, where x is the minus 1 plus 2 root 3. Okay, and then when I substitute this into here, I get y equals 4. Okay, and that is the answer, because it was the imaginary value that we're looking for. Okay, so the maximum imaginary value of z is just 4. And there we have the final one. Now this final part in this question was quite awkward numbers, and I think being a past paper question, if I'd seen this in the exam and then I was doing these numbers, I would probably think I've done something wrong. It's ended up with a nice simple answer in the end, but this whole working out, I would have looked at it and thinking I've done something wrong here. And obviously with this, using the quadratic formula, I've just used the solve equation function in my calculator with my a, b and c, and I could have done it with a, b and c here. But if I'm using that equation function in my calculator, I should always write this step down in my working out, so that I guarantee I get the full marks. I shouldn't jump straight from here to here. Okay, so there's that. Hopefully you found this video useful, and I'll catch you in the next one. Don't forget, like, subscribe, and if you're willing and able to help me out financially, then please consider hitting that join button, even if you just join for 1 month. It is most appreciated. See you next time.